chapter 1-1 real numbers and their graphs. I'm going to give you the definition of natural numbers. They can be 1, 2, 3 to infinity. So anything that is positive and greater than 0. So it can't include 0. So 1 all the way to infinity. Those are natural numbers. Then we have whole numbers. The only difference between natural numbers and whole numbers is that whole numbers do include 0. And they are greater than or equal to 0. So they're positive and greater than or equal to 0. Integers are both positive and negative numbers. So you could have -3, -2, -1, 0, 1, 2, 3, all the way to infinity. So anything negative or anything positive. And then you have rational numbers. Rational numbers are fractions or a decimal that can be written as a fraction. So, for example, you could have -5/3, 7/9, 0.5, because that's really 1/2, because it can be written as a fraction. It can be written like this. Or 4/1, because 4/1 is the same as 4, and that's a whole number. So you have to take into account your whole numbers as well. Irrational. Irrational numbers are numbers that cannot be written as a fraction. Some examples of those would be 2.56789. They're just random decimals that go on forever. Radical 2, because if you plug radical 2 into your calculator, you will get a decimal that goes on forever. And pi would be an example, because pi is really 3.14 and it goes on forever. So the most difficult part is remembering what the difference between rational and irrational numbers, and just remember that rational are a fraction or decimals that can be turned into fractions, and irrational are numbers that can. Example number 1, find the point give you different points, and it's going to give you C, D, E, F, G, H, and I. And C is at -5, so this is -4, -3, -2, -1, 0, and 1. And it wants you to find the point 2/3 of the way from C, which is this one right here, to I. So your first step, step 1, is to find the distance from C to I. So we are going to count over how many we have. So we have 1, 2, 3, 4, 5, 6. So it's a distance of 6 between C and I. So we have 6 units. Then you would have step 2. You're going to multiply 2/3 by 6. So you have 6 times 2/3, because it's 2/3 of the way. You're trying to find 2/3 of the way between C and I. So when you do that, you would have 12 divided by 3, which is 4. Step 3, you are going to move 4 units from left to right. So we found out that it's 4 units, so we have to go over 1, 2, 3, 4. And right here on G, which is -1, is the 2/3 point between C and I. So I would write -1 as my answer, because it's 2/3 of the way from C to I. Final answer. We're going to talk about inequalities and absolute values. So inequalities are like greater than, less than, greater than or equal to, less than or equal to, or equal to. Okay, so here's your inequalities, and you need to understand that if I had -3 and 1, you would know that -3 is less than 1 because it's more negative. Okay, so you'd rather have $1 than owe somebody $3, so it's less than. Absolute values if you have the absolute value sign with a positive number, so we have +5 in the absolute value sign, you know that your answer is just going to be 5, positive, no matter what. If it were the absolute value of -5, you know that it shoots out a positive number as well. So it doesn't matter if it's positive or negative, if there's absolute value signs around it, you always get a positive number. The absolute value of 0 is just 0. Here's where it gets a little bit more tricky. If you have a negative and inside you have the absolute value signs, you have a -4. So on the outside you have a negative and on the inside you have a negative. Well, if we look at just the absolute value of -4, we know that that's 4. But because there's a negative sign on the outside, you have to include that as well. So your answer would be -4. If you were subtracting the absolute value of -6 minus the absolute value of 6, you would know that the absolute value of -6 is 6, the absolute value of 6 is 6, and 6 minus 6 is 0. So you look at both of them separately and then subtract them.